Hello everyone. Um, Hello everyone. Good evening. So here we shall start the today's live class. Here we shall solve some KCET previous year questions on the chapter work, power and energy. If you have any doubts regarding any question or its solution, then please write us in the comments section. And if you feel that you have more difficulty in any chapter, then also please mention the name of that particular chapter in the comment section so that we can give more priority on it and solve more questions on that chapter. Also, homeworks on every chapter will be uploaded on the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So we shall start off with the first question. So it is told that a shell of mass 20 kg which is kept at rest. A shell is there which is of mass 20 kg that is kept at rest m, and it explodes into two fragments whose masses are in the ratio 2:3. It means that one of the masses are 2m by 5 and one mass is 3m by 5. The smaller fragment moves with a velocity v1 which is 6 meter per second. The kinetic energy of the larger fragment will be how much? Now let's say the velocity of the larger fragment is v2, which will be obviously in the opposite direction. Since why we have to apply the conservation of linear momentum. So by applying the law of conservation of linear momentum, we get that 2m by 5 into v1 minus 3m by 5 into v2. So actually it is plus of minus v2. Since why, if you take the direction of the velocity of the smaller fragment is positive, then the direction of the velocity of the larger fragment would be obviously negative. So that is equal to m into 0. Since why, the initial velocity of the shell was 0 since it was initially kept at rest. So therefore we can say that 2m v1 by 5 that is equal to 3m v2 by 5. So m by 5 will cancel. So from here v2 will be equal to 2 v1 by 3. So which is 2 by 3 into 6 meter per second. 6 meter per second, which is equal to 3 2s are 6. So 2 2s are 4 meter per second. So therefore now 3m by 5 that is equal to 3 by 5 into 20 that is 5 4 the 23 4 the 12. So therefore the kinetic energy of the larger fragment, that is the kinetic energy of the uh, second fragment, we can say, so that will be equal to half m, which is 12 m into v square. So 2 6 are 12, 6 into 16, 16 6 are 96 joule. So option A is the correct answer. Option A is the correct answer. So in any of the steps, if you are unable to understand or any doubts if you have, then please write us in the comment section. Here it is told two rectangular blocks A and B of masses 2 kg and 3 kg respectively are connected by a spring of spring constant 10.8 Newton per meter. There is a spring which is which connects two masses, one is A and one is B. Spring constant, that is K is equal to 10.8 Newton per meter, and are placed on a frictionless horizontal surface. The block A was given an initial velocity of 0.15 meter per second, and the surface is frictionless, so mu equal to 0. Block A was given an initial velocity of this, which is velocity of block A. The maximum compression of the spring during the motion is, so the maximum compression will come when both will have the same velocity. Maximum compression so it is of mass of the block A is 2 kg and mass of the block B, that is 3 kg. Now therefore we can say that MA into VA, it is actually UA, actually MA into UA, that is equal to, so what will be the common velocity that we have to find first? That is equal to MA into VA, MA into V plus MB into V, by applying the law of conservation of momentum. So by the principle of conservation of linear momentum, principle of conservation of momentum, you can say that the final the initial momentum equal to the final momentum. So therefore V will be equal to, the common velocity is V, so that is MA into UA divided by MA plus MB. So that will be MA is 2 kg and UA is the initial velocity of the object, the block A, 0.15 divided by 2 plus 3. So that is 2 by 5 into 0.15. 5 3 is 15, 3 is 6, so 0.06 meter per second. So now to find the maximum compression, here we have to apply the conservation of energy. It means since the floor is frictionless, so therefore there is no loss of energy due to friction. So therefore it means that the initial kinetic energy plus spring potential energy, the initial kinetic energy of the system plus the potential energy of the spring, that is equal to the initial, that is equal to the final kinetic energy plus the final spring potential energy. So the initial kinetic energy will be equal to half mv square, plus so initially the spring is not compressed or in the extended state. It is 0. The spring potential energy, that is half kx square, where k is the spring constant, So that will be equal to final kinetic energy, that is half m into v square plus half m into v square 0.06 whole square plus half kx square, So therefore we can say that this will be so all these halves I can cancel out, all these halves. So then that will be 2 into 0.15 square, that is 15 square is 225, so that is 0.025, that is equal to 2 into 2 plus 3, 5 into 0.06 whole square, that is 0.0036, plus this is 108 x square, where x is the maximum compression in the spring. So then we can say 108 x square, that is equal to 2 into this, that is 0.02 to the 450, minus this is 5 into this, that is 5 6 are 30, which is 15 18, so it is 0.018 180. So x square will be equal to 0.0180, that is 0.067 to 27 divided by 108. So therefore x square is coming this much in meters, which is 0.027 by 108 meters. So that will be equal to, you can cancel out with 27 only, so that is 0.001, 27 ones and 27 fours are, that is 1008. Okay, so then this will be 100, so I can say this will be 0.0025. Okay, x square is, this is 10 power minus 3 divided by 4 x square, that is so then this will be maximum compression. So okay, sorry, this will be 10.8. The spring constant is 10.8, it is not 108. Okay, 10.8, this is 10.8 x square, this is 10.8, so this is 0.4, this is 10 power minus 3 divided by 4 into 10 power minus 1, so this is 1 by 400. So therefore x will be equal to 1 by 20, which is equal to 0.05 meters. So option C is the correct answer. Then here it is told to find the work done by a force acting on a body is shown in the graph. The work done by a force acting on a body as shown in the graph. So this is displacement, this is force. So this is the graph. The total work done in covering an initial distance of 20 meters. The work done in covering a total initial distance of 20 meters, that we have to find. So we know that work done is area under the force versus displacement graph. So the area we have to find, that is, so this will be, as we can see, this is 20 and this is 5, and then this one is 20, this one is 10. Okay, so the area of this part, that will be half into base which is 5 meter into height is 10 Newton, then plus half into base into height, base is 5 meters, this is 5 meter into, this will be 20 minus 10, this is 10 Newton, then plus this is area of the rectangle, that is length 20 minus 5, that is 15 meter into 15 meter into 10 Newton. 15 meter to 10 Newton. So 5 into 10, that is 50 Newton meter. So Newton into meter, that is joule. So I can say 50 joule plus 150 joule. So that will be 200 joule. So option B is the correct answer. We have actually found the area of this part, which is this, and found out the area of this triangle, and found out the area of this rectangle, that is 150. Then in this question it is told to find that if the linear momentum of a body is increased by 50%, then the kinetic energy of that body increases by. So we know that kinetic energy, that is given as p square by 2m, where p is the linear momentum of the body, p is the linear momentum, and m is the mass of the body. So therefore you can say that delta k by k into 100, okay, sorry, this is increased by 50%, so the change is not small. So the initial kinetic energy that we can say it is p square by 2m. Now p is the linear momentum is increased by 50%. It means p is changed to p plus 50% of p. So that is p plus p by 2. That is 3p by 2. It means that the new value of new momentum, the new momentum is p1, that is equal to 3p by 2. Now the new kinetic energy, that is suppose k1, that we have to find, which is p1 square by 2m, since the mass will not change. Mass will not change. So 3, so p square is 3p by 2 whole square by 2m. So that will be 9p square by 4 into 2, that is 8m. K1 is 9p square by 8m. So this we can write, this is 9 by 4 into p square by 2m. It means that the new kinetic energy is 9 by 4 times the initial kinetic energy. So therefore the percentage increase in the kinetic energy, is k1 minus k by k into 100%. So that will be 9 by 4k minus k, so it is 1 by 1 into 100%. So that will be 5 by 4 into 100%. So that is 425 is 100, which is 125%. So there is a 125% increase in the kinetic energy. So option B is the correct answer. Then here it is told that body of mass 5 kg is thrown vertically upwards with a kinetic energy of 490 joule. So that is half mu square, that is equal to 490, and the mass is 5 kg. So therefore from here we can find out the initial velocity u square will be 490 into 2 by m is 5. So we can say into 2 we can do, so 10, so that is 49 into 4. So u will be equal to 7 into 2, which is 14 meter per second. And the height at which the kinetic energy of the body becomes half of the original value. We have to find the height at which the kinetic energy of the body, the final kinetic energy should be half of the initial kinetic energy. At which height, that we have to find. So we know that v square equal to u square minus 2gh. Since g is acting opposite to the direction of motion here, so we should take minus g. So final velocity will be v square equal to u square minus 2gh. So that height we have to find. So now it means that half mv square, that is equal to half mu square minus mgh. So that is equal to half of the initial kinetic energy, which is half mu square. So that height we have to find. So therefore that is half of half mu square, half of the initial kinetic energy. So that is 1 by 4. So it means that we can say half mu square to 1 minus half, that is equal to mgh. So m and m will cancel. So h will be equal to, this is half, so this is u square by 4g. So u square is 49 into 4 divided by 4 into g, that is 9.8. So that is 98 by 10. So that 10 will go up. 4 and 4 will cancel. 49 2s are 98. So 2 5s are 10. So height is equal to 5 meters. It is equal to 5 meters. So therefore option A is the correct answer. So in any of the solution steps, if you are unable to understand, or any other doubts if you are having, or if you feel difficulty in any other chapter, then please write them in the comments section. Then here it is told that two bodies of masses m1 and m2 are acted upon by a force F for a time t. Here we have one mass m1 and here we have one mass m2. So m1 is acted upon by a force F for a time t, and m2 is acted upon by a force F for a time t. They start from rest. So u1 equal to 0 and u2 is also equal to 0, and acquire kinetic energies E1 and E2 respectively. So the final kinetic energy is E1 here, Ke1 final, and the final kinetic energy of the second mass is also E2. Then we have to find the ratio of E1 and E2 time t. So we know that force equals to mass m1 into acceleration a1. So a1 will be equal to F by m1. Now therefore for a time t, so E1 will be equal to u1 plus a1 into t. So that will be 0 plus ft by m1, and the final velocity of the second mass, that will be 0 plus ft by m2, which is u2 plus a2 into t. Here also from here you can say F equal to m2 into a2. So a2 will be F by m2. So therefore the final kinetic energy, that will be half m1 into v1 square, and E2, the final kinetic energy of the second mass, that will be half m2 into v2 square. So therefore E1 by E2, that will be equal to M1 V1 square by M2 V2 square. So that is M1 into V1 square, that is Ft by M1 whole square, divided by M2 into V2, that is Ft by M2 whole square. So that will be equal to F square T square by M1, since it is M1 square and M here, so M1 and this square will cancel out, and this is F square T square by M2. So this will be M2 by M1. F square T square will cancel. So that is M2 by M1. So option B is the correct answer. Okay, then it is told that a gun fires a small bullet. A gun is there which fires a small bullet with kinetic energy K. Kinetic energy, that is half mu square. The kinetic energy of the gun while recoiling. So suppose the mass of the bullet is small m and mass of the gun is capital M. So the kinetic energy of the gun while recoiling. So the velocity of the recoil, that is suppose Vr. Now we know that kinetic energy is equal to P square by 2m, where P is the linear momentum of that object. So now here, by principle of conservation of momentum, their linear momentum will be opposite, but their magnitude will be the same. It means the linear momentum of the bullet, that is equal to minus of the linear momentum of the gun. Since why? The linear momentum of the bullet is mu, where u is towards suppose I cap, it is mu I cap, and that is equal to minus of m into capital M into Vr minus I cap. So therefore we can say that mu, that is equal to m into Vr, obviously, where capital M is the mass of the gun and Vr is the velocity of recoil of the gun. So therefore Vr, that is okay. So now therefore Vr, that velocity of recoil is mu by capital M. So now the kinetic energy of the gun, that will be equal to half mu square, and kinetic energy of the bullet, is half mu square, and kinetic energy of the gun will be half capital M into Vr whole square. So that is half m into Vr, which is mu by m whole square. So that is half mu square divided by m into 1 by capital M. Half m square u square divided half m square u square by capital M. So you can say it is m by m into half m u square. Now mass of the bullet is obviously less than mass of the gun. So m by m, this fraction is obviously less than 1. So it means that kinetic energy of the gun, that is obviously less than kinetic energy of the bullet. So the kinetic energy of the gun while recoiling is less than k. So option C is the correct answer. Then in question number 8, it has been told that from a fixed support, two small identical spheres are suspended by means of string of length. So these are two identical spheres which are suspended by means of strings of length 1 meter. The length is 1 meter. Lengths are 1 meter. They are pulled aside as shown and then released. B is the main position. Then the two spheres collide. Where they will collide, that we will find. So they are initially so this string, suppose it is string S1, this is string S2. String S1 is pulled from the vertical at an angle of 60 degree, and S2 is pulled at an angle of 30 degree to the vertical. So where they will collide, that we have to find. Okay, so now their time period. Okay, so here the time, the two spheres will collide at B after 2 seconds, 25 seconds. The right of B after some time. The right side of B when the strings are inclined. Okay. So obviously they are identical spheres. It means that and G is acting vertically downwards. So this acceleration is G sine theta. So G sine 30 degree, that is G by 2, and this is G sine 60 degree, that is G root 3 by 2. So actually at an angle theta, when the angle is theta, then we know that if it is inclined at an angle theta, pulled at an angle theta, and then it is released, then this angular acceleration is G sine theta. So therefore G sine theta, we can say G sine theta, that is equal to L into alpha. Alpha is the angular acceleration, which is d square theta by dt square. So it means that this angle is smaller. It means that this will cross B first. This sphere will cross the point B at first, and then after that this will cross. It means that they will meet on the right side of B, obviously. So they will collide on the right side of B after some time. So option C is the correct answer. Then in the question number 9, it is told a truck accelerates from speed v to 2v. A truck is there which accelerates from the speed v to the acceleration to the speed 2v. So here the acceleration is a, suppose the acceleration is, so work done in work done during this is accelerating it from rest to, okay. So we have to find how that how much times is this work done. Suppose I take right that this work done is W2, then, and if the work done to take it from rest from v equal to 0 to v, here the work done to accelerate it from rest to v, that is suppose W1, then W1 is how many times W1. It means that if W1 is equal to n into W1, then that n is how much, that we have to find. So now we know that work done equals to change in the kinetic energy, work done by all forces. work done by all forces equal to change in kinetic energy, which is called as the work energy theorem. Work energy theorem. So therefore W2, the work done, that is equal to half. So it is final kinetic energy minus initial kinetic energy that we have to do. So which is half m. Suppose the mass of the truck is m. We consider it. So that is half m into 2v whole square minus half m into v square. So that will be half m, I can take as common, then this will be 4v square minus v square, that is 3v square. So that is 3 into half mv square. And then W1, it will be equal to half into it is half m final kinetic energy, half m v square minus half m into 0 square. So that will be half m v square only. So therefore W2, that is equal to 1 by 3 times W1. So W1 is more. W1 is 3 times of W2. Sorry, W2 is equal to 3 times of W1. Sorry, W2, that is equal to W2 is equal to 3 times of W1. Means that the truck work done in accelerating the truck from speed v to 2v is 3 times as the work done in accelerating it from rest to v. So option A is the correct answer. Then in question number 10, it has been told that the kinetic energy of a body of mass m 4 kg and momentum 6 Newton second will be. So we know that kinetic energy equals to p square by 2m, where p is the linear momentum of the body. P is the linear linear momentum of that body. So now therefore the required kinetic energy, that will be p square, which is 6 Newton, 6 square by 2m, 2 into 4, mass is 4. So this is 36 by 2 into 4, 4 nines are 36, so 9 by 2, that is 4.5 joule. So hence option D is the correct answer. So in any of the steps, if you are unable to understand in the solution, or any other doubts if you are having, then please write us in the comments section. In this question, it is told a 12 kg bomb which is kept at rest. A 12 kg bomb is there, which its mass is m, which is 12 kg. It explodes to two pieces, m1 and m2, which is m1 and m2, whose masses are 4 kg and 8 kg respectively, and it is initially kept at rest, which is, so initial velocity is 0, initially at rest. If the momentum of 4 kg mass, that is p1, that is 20 Newton second, then the kinetic energy of the 8 kg piece, means kinetic energy of the second mass, that is how much, that we have to find. So now by the principle of conservation of linear momentum, by the principle of conservation of linear momentum, we can say that p1 minus p2, that should be equal to 0, or p1 plus p2, that should be equal to 0. It means p1 is the linear momentum of the first object, that is m1, and p2 is the linear momentum of the second fraction, which is m2. Therefore we can say that m1 v1 plus m2 v2, that is equal to 0, since why initially the bomb was kept at rest. So therefore P2 also will be equal to actually minus 20 Newton second. So this negative sign shows that the second piece will go in the opposite uh, direction of m1, means m2 will move in the opposite direction of the mass m1. So now therefore the the, the kinetic energy of the 8 kg piece, that is p2 square by 2m2. So that is, since we know kinetic energy is p square by 2m, so that will be minus 20 whole square by 2 into m2, that is 8. So that is 200, so 400 by 2 into 8, so 5 8s are 40, 0, then 2 25, so that is 25 joule. So option A is the correct answer. Then question number 12, it is told that a motor pump lifts 6 tons of water, 6 tons of water. So now 1 ton is equal to 1000 kg. 1 ton is 1000 kg, so 6 tons means it is 6000 kg. So 6000 kg water is lifted up from a well, lifted up from a well of depth 25 meters. The depth of the well is 25 meters to the first floor, to the first floor of height, to the first floor of height 35 meter from the ground in 20 minutes. So in 20 minutes this 6,000 kg water is being lifted up from the well to the first floor. The power of the pump in kilowatt is, we have to find the power of the pump. So we have to actually find the average power of the motor pump. So the average power of the motor pump, that will be equal to the total work done by the total time taken, which is in 20 minutes time. So total work done by the total time. So therefore now the total work done that is equal to so that is mg into h plus d actually, since the water is lifted from the depth of the well to this height, to the first floor. So h plus d we have to do, where h is the height of the first floor from the ground level. Now this is the ground level, and the depth from which the water is being lifted up is 25 meter below the ground level. So mg is the upward force which it has, so that the lift has to apply, so as to lift this water. So the mass is 6000 kg, so 6000 into g, we have to take 10 into h plus d, that is 35. H is 35 plus 25 meters, so this much joule. So 25 plus 35 is 60, so 60 into 10, that is 600 into 6000 joule. This is the total work done by the lift pump, actually. Therefore the total time required to do this work is 20 minutes. So 20 minutes is equal to 20 into 60 second, since every quantity we have to use in the SI unit. So therefore the average power of the pump, that will be total work done, which is 600 into 6000 joule. Now joule per second is what? Joule per second, we can say it is watt. So 60 and 1 kilowatt, that is equal to 1000 watt. So this is 60 into 6000 divided by 20 into 60, this much watt. So 60 and 60 will cancel, 0 will cancel, and 300. So this is 300 watt. So I can say it is equal to 0.3 into 1000, so 0.3 kilowatt. 20 minute. Okay, so 60 and this will be 10 actually. 60 10 is 600, so 2 3 so this is 3000 watts, so this is 3 kilowatt. So option D is the correct answer. So 3 kilowatt is the answer. It means that option D is the correct answer. Then the question number 13, it is told that two particles of masses m1 and m2 have equal kinetic energies. So it means that kinetic energy of the first particle having mass m1 is equal to the kinetic energy of the second particle which has the mass m2. So the kinetic energy of the first particle which has mass m1 is same as the kinetic energy of the second particle which has mass m2. So therefore kinetic energy of the first particle, okay, we have to find the ratio of their momenta. Kinetic energy we can say that is p1 square by 2 m1, so that will be equal to p2 square by 2 m2. This is given. Since we know that kinetic energy is p square by 2m, where p1 is the linear momentum of mass m1 and p2 is the linear momentum of mass m2. So we have to find the ratio of m1 and ratio of p1 and p2, p1 by p2, that we have to find. So p1 square by p2 square, that is 2m1 by 2m2. So 2 and 2 will cancel out, so p1 by p2, that is equal to square root of m1 by m2. So that will be equal to root m1 by root m2. So the required ratio is root, so therefore we can say p1 is to p2, that is equal to root over m1 is to root over m2. So option C is the correct answer. Then question number 14, that is, during inelastic collision in between two objects, which of the following quantity always remains conserved? The total linear momentum always remains conserved. Speed of each body does not remain same. Total kinetic energy also will not remain the same. Since in inelastic collision there is always a loss of kinetic energy, and total mechanical energy that also always does not remain conserved, since during collision some friction can act, so due to which there can be a loss in the total mechanical energy also of the system. So therefore only the total linear momentum remains conserved during any kind of collision. So during inelastic collision. So option A is the correct answer. Then we shall solve the last question of this live class. Okay, so here it is told that body is initially at rest. So body is there whose initial velocity is 0. Its mass is suppose m. Since y initially it is rest, so we should take u as 0. It undergoes one-dimensional motion with constant acceleration. So the acceleration a, that is constant, and the power delivered to it at time t is proportional to. So we have to find that the power that is delivered to it, that is proportional to t raised to how much? T raised to n, so that n we have to find t raised to n. So now acceleration is constant, so the power is actually force into velocity. Power is force into velocity. So v is equal to u plus at. So that will be equal to at only, since initial velocity is 0. And the force, constant acceleration, so force is equal to mass into acceleration. One dimensional motion. Okay. So since acceleration is constant and mass also cannot change, so the force is also constant. So therefore power is equal to force, that is ma into at. So that is ma square t. So now ma square is constant, so therefore power is proportional to t. So option D is the correct answer. So hope you have understood all the uh, solutions of these 15 questions, and in any of the solution or in any question, if you are unable to understand or any doubts if you are having, then please write us in the comments section. We shall obviously clarify them in the subsequent live classes. So thank you everyone. Bye.